Non-Cartesian case-space data, which is time-consuming due to the repeated application of forward and adjoint Fourier encoding operators. While efficient implementation of a non-uniform FFT like phi-NUFT and Q-phi-NUFT make this reconstruction clinically feasible in most applications, for high-dimensional data, such as 3D multi-contrast acquisition like MR fingerprinting, runtime is still too low to be practical. GROG, which is a graph-based interpolation to a Cartesian grid, can overcome this issue by using a single non-iterative interpolation step to Cartesian grid to replace the non-uniform FFT with cheap uniform FFTs. Despite its advantages, to the best of our knowledge, no feature-rich GROG standalone packages for multidimensional data are currently available, so we wanted to fill this gap. So our package consists in several modules. We have a calibration module that contains several utilities to perform coil compression and reduce the GROG interpolation time, and a JSense-based coil sensitivity mapping routine, which also synthesizes fully sampled raw resolution case-space data for GROG training, hence enabling application of this method to arbitrary trajectories without the need of an explicit calibration dataset. Then we have the actual GROG module that contains the routines to calculate these grappa kernels and pre-compute the interpolation plans solely based on trajectory, hence enabling fast runtime interpolation of the actual samples. Then we have a Fourier module that contains efficient implementation of sparse uniform FFT routines to be used after GROG interpolation within our iterating algorithms instead of the NUFT. And finally, we have a gadget module that contains extended signal modules to approximate of resonance effect and enable low-rank subspace projection. Benchmark our implementation, we measure the forward and adjoint runtimes for a low-rank subspace reconstruction of a public 3D MR fingerprinting dataset. And as you can see here, the GROG interpolation enabled on GPU order of magnitude speed up compared to the state-of-the-art Q-phi-NUFT library. So thank you for your attention.